Here's problem 3121. A rectangular coil of 100 turns measures 40 centimeters by 20 centimeters. This coil is placed next to an electromagnet, which is switched on, increasing the magnetic field through the coil from 0 to 0.8 Tesla in 50 milliseconds. If the resistance of the coil is 2 ohms, what are the induced voltage and current in the coil? Alright, so the number of turns is 100, and our area is going to be equal to 0.4 meters times 0.2 meters, or 0.08 square meters. We have our change in magnetic field, which is our final magnetic field minus our initial magnetic field. It's going to be 0.8 minus 0, or 0.8 Tesla. And our change in time is going to be 50 milliseconds. And the resistance of the coil is 2 ohms. So a lot of things given. We have that the magnitude of the average EMF induced will equal the number of turns times the change in flux, change in time, at least the magnitude of it. And that's going to be equal to the number of turns times the area times the change in magnetic field per change in time, because the orientation is not changing and the area is constant. Let's take that out of the change here. 100 times 0.08 times 0.8 over 50 times 10 to the minus 3, and this is equal to 128 volts. So our current is equal to this EMF divided by the resistance. 128 volts divided by 2 ohms, 64 amps. So that is the induced voltage and current, 128 volts, 64 amps in the coil.